This is lesson 3.5. In lesson 3.5, we're going to be talking about a form of linear functions. So it's called standard form. And in standard form, we have the equation ax plus by equals c. So this is our standard form equation here, one that we'll want to memorize. And one thing that we need to point out, a, b, and c are real numbers. A and b are both not 0. So a and b cannot be 0 in standard form. So what this form helps us to be able to do is it helps us to be able to figure out the intercepts, the x and y intercepts of a linear equation. A couple things I want to mention is we have horizontal lines, and if you'll notice, that would be y equals b in this case. So it goes right through that y-intercept where it touches. That's what the number is, so y equals that number. If it's a vertical line, then it's y equals the number that it touches the x-axis on. So this would be x equals a, or maybe x equals 5, depending on where it's touching that x-axis. So when we look down here, we've talked about x and y intercepts before, but now we're going to figure out how to find these x and y intercepts. So the x-intercept is when y equals 0, and now we solve for x. And for our y-intercept, it's when x equals 0, and we're solving for y. So if I'm looking at example 1, and it says, use intercepts to graph the equation. So I notice ax plus by equals c. It's written in standard form. So in example 1, I have the equation 3x plus 4y equals 12. So if I want to graph my x and y intercepts, then I have to take them one at a time. So let's, for example, start with our x-intercept. So for our x-intercept, we have to plug in 0 for y. So y is here. So we have 3x plus 4 times 0 equals 12. So 3 times x, actually I feel like I should use a different color here. Let's change that y in 0 to blue. There we go. So we have 3 times x, which is 3x, plus 4 times 0 is 0, equals 12. So we've got 3x equals 12. If my goal is to get x by itself, I need to divide both sides by 3. When I do that, I discover that x equals 4. So if I want to write this as a point for my x-intercept, remember my x value always goes first, so it's the point 4. And I plugged in 0 for y, so it'll be 4, 0. That's my x-intercept. Now I'm going to do the same thing with my y-intercept. However, this time, because I want to solve for y, I have to plug in 0 for x. So I'm going to have 3 times 0 plus 4y equals 12. 3 times 0 is 0 plus 4y equals 12. So we know that 0 plus 4y is just 4y. In order to get y by itself, we're going to divide by 4. And when we do this, we realize that y equals 3, because 12 divided by 4 is 3. Now remember, y value in our point always comes second. So 3 is the y value, and we plugged in 0 for x. So our two intercepts that we can use to graph this line are 4, 0 and 0, 3. So over 4 up 0, and over 0 up 3. So I've got my two dots. This is a linear function here. So we're going to connect them with a line. And there we have it. That's the line for this equation using our x and y intercepts. All right, take a look at example 2. You're planning an awards banquet and need to rent tables to seat 180 people. There are 2 table sizes available. Small tables seat 6 people and large tables seat 10 people. The equation 6x plus 10y equals 180 models this situation. So if we look at it, we have small tables are represented by x because 6 people can sit at the small table. And the large tables are represented by y because large tables can seat 10 people. So we had small tables were x and large tables were y. All right, keep reading. X is the number of small tables, y is the number of large tables. So we're going to graph this equation, and we're going to interpret the intercepts. So we're going to figure out what those mean. And then we're going to find 3 possible solutions in terms of this problem. Okay. So first, let's use our knowledge about x and y intercepts to figure out how to graph it. So for example 2, our equation is 6x plus 10y equals 180. All right. So let's start by finding our y-intercept this time. So we've got 6 times 0 plus 10y equals 180. So 6 times 0 is 0 plus 10y equals 180. 0 plus 10y is 10y equals 180. To get y by itself, we're going to divide by 10. So y equals 18. And remember that this would be the point 0, because x was 0, 0, 18. And if we're interpreting this, what this means is that we, in order to satisfy the people that they're trying to satisfy, seat the right amount of people, we could have 18 large tables and 0 small tables. Then it would accommodate as many people as they were looking to accommodate. Now let's try to find our x-intercept. We're going to plug in 0 for y equals 180. So something I want you to notice, anytime we plug in 0 for one of these variables, it makes that entire thing simplify down to just what we started with. So if you're seeing this pattern and you want to just skip a couple of steps, instead of writing 0, you could cross this off if you want to. You could skip right to writing 6x equals 180. because you're noticing that pattern. As long as you're not making silly mistakes, that's totally acceptable. So divide both sides by 6. We're going to get that x equals 30. So this would be the point, because remember, x value is 30, so that goes first. We plugged in 0 for y. So if I'm going to interpret this data, it means that we have 30 small tables and 0 large tables this time. So that was part A. We graphed the equation and we interpreted the intercepts. Oh, we didn't graph it. We just interpreted the intercepts. So we have 30, 0. So let's count these. We'll do 5, 10, 15, 20, 25, 30. So we have 30, 0. And then we had 18, 0, 18. So we'll count those ones by 3s. So 3, 6, 9, 12, 15, 18 right there. So there are our 2 intercepts. And we have to pick 3 possible solutions that would work for this one. So if we're looking at it, right, we got to find a spot on this line. So it looks like we have a spot right here. So we had 5, 10, and going up we had 3, 6, 9, 12. So 10, 12 is the point that we're looking at right here. So the point was 10, 12. And what that means, because we had 10 on the x, right here 10, and we had 12 on the y, that means we could have 10 small and 12 large. And then we also could use our intercepts that we have here, right? We could have 18 large tables and 0 small tables. So that's the point 0, 18. Or we could have 30 small tables and 0 large tables. 30, 0. So all 3 of those would be possible solutions or combinations that we could use. There are others as well. We could look at the graph to find more. But those are 3 that we could use to get that information. This is lesson 3.6a. In this lesson, we're going to be talking about slope. And something that you're going to notice is that slope is very similar to something we've already talked about, which is a constant rate of change. So when I'm looking at slope in our, they refer to it as m, which you've seen that before, like when our, we have that y equals mx plus b formula or equation that we use for our lines. So m is the slope. And we find that slope, or that m, by doing rise over run. And sometimes the way that I like to write it as a reminder is I change the spelling of the word rise and I make it with a y. And I do that because it reminds me that the rise is the change in the y value and the run is the change in the x value. So I change the spelling of the word rise and I put a y in it. So I remember, hey, y is the one that has to go on top. And it always has to go that way. So here we've got our rise and our run is this part right here. So they also give you a formula right here. So if you have 2 points, you can do y2 minus y1 over x2 minus x1. It's a little bit hard to see there a little bit. So just depending on what information you're given will determine which thing is going to be best for you to use when you're trying to find the slope from the lines. So when I'm looking at my graph and I want to find the slope of this graph, one thing that I would do is I look at, okay, so I pick 2 points. So these 2 points are already labeled for me. And I say, okay, the rise, so to get from where this one starts and where this one ends, right? What is the change? The change is 1, 2. I went down 2. And then I ran 1, 2, 3, 4, 5. And I ran 5 to the right. And remember that moving right is a positive direction. So that number would be a positive 5. Since I can't simplify this slope, 2/5 can't be simplified any more than it is right now, then I would simply write it as negative 2/5. If you were to use this formula up here that they have, then you would have the points that they gave you. So we had negative 4, 3. And the other point we had was 1, 1. So what I do when I'm trying to use the formula is I label which is which. And it truly doesn't matter as long as I call them both the same 1 or 2. So for example, if I call this one y1, then this one's y2, which means that this 4 would have to be x1 and this one would have to be x2. So it doesn't matter which is 1 and which is 2, but I have to make sure that I label them the same within their point. So it says y2 minus y1. So y2 is 1 minus y1, which is 3, over x2, which is 1, minus x1, which is negative 4. So I want to show you this. Minus and negative. Remember, we've seen stuff like that before. We need to make our lives simpler. When I am subtracting a negative, remember, I'll do keep, change, change. So that becomes 1 plus 4 on the bottom because I was trying to subtract a negative. So this will simplify. 1 minus 3 is negative 2. And 1 plus 4 is 5. So notice, I still got the same slope. I just used the formula instead of the graph. For letter B, I again have 2 points. So I'm going to move. I'm doing my rise. So I have down here to up here. So I rose 1, 2, 3, 4 spaces up. And 1, 2, 3, 4, 5, 6 spaces to the right. So for B, I have 4 over 6. But this time, both of those numbers can be reduced by 2. So 4 divided by 2 is 2, and 6 divided by 2 is 3. So anytime we can simplify our slope into a more simplified fraction, then I would suggest that. Sometimes they're going to simplify to a whole number. It's okay to simplify to a whole number, but I want to encourage you, never, never, never simplify to a fraction, to a decimal, because if you leave it as a fraction, I know that the top is my rise and the bottom is my run, and I could use that to make more dots on my graph. So look, I could use up 2, 1, 2, and run 3, 1, 2, 3. Look at that, I'm right back on the line. Rise 2, 1, 2, run 1, 2, 3, right back on the line. So I encourage you to always write your slope as a fraction or a whole number, which if you use a whole number, remember that the bottom would be a 1, but that's going to help in the long run. So stay away from decimals for your slope, leave them as fractions, and especially leave them as improper fractions. I would not change them to mixed numbers. That would make life way too complicated. All right, for example 2, we're looking again at the change in the y over the change in the x. We've done this before with rate of change. So from 20 to 14, we went down 7. 14 to 8, we went, oh my goodness, we went down 6, Mrs. Weber. From 14 to 8, we went down 6, and from 8 to 2, we went down 6. Then we have from 4 to 7, we went up 3. 7 to 10 was up 3. 10 to 13 was up 3. So these all are the same. So I'm just going to have to simplify one fraction, really. So I have negative 6 over positive 3. Well, negative 6 divided by positive 3 equals negative 2. So my slope for that one is negative 2. All right, from 2 to 2 is 0. From 2 to 2 is 0. From 2 to 2 is 0. Negative 1 to positive 1, we go up positive 2. 1 to 3, we go up 2. 3 to 5, we go up 2. So again, all these ones were the same. So it's 0 over 2. And 0 divided by 2 equals 0. So the slope for this one is 0, which means that it is a horizontal line, so a flat line. All right, next one. From negative 3 to 0, we went up 3. From 0 to 6, we went up 6. And from 6 to 9, we went up 3. On the x side, from negative 3 to negative 3, we went up 0. Negative 3 to negative 3 is 0. Negative 3 to negative 3 is 0. So what I have here is two of them are the same. So I have 3 over 0. And then I have 6 over 0. Here's the problem. We cannot have fractions with 0 on the bottom. I can't take three things and give them to no one because I still have them and I'm a person, right? So whenever you have a slope with a 0 on the bottom, we label this as an undefined slope. And what you're going to discover is that when your slope is undefined, it is a vertical line. So I'm going to introduce you to my pretend friend, Steve. My pretend friend, Steve, can only walk to the right. So what happens when my pretend friend, Steve, walks to the right? I have this line here like this. Here's my pretend friend, Steve. He's always walking to the right, so he's going this way. What's happening as he walks to the right? He is moving up, which means that any line that looks like that would have a positive slope. The next one that we're going to look at for my pretend friend, Steve, is, again, he can only walk to the right. So if my friend Steve walked to the right here, he's moving down. And down would signal that we have a negative slope. Then we have the most boring ski slope in the entire world. Steve's basically just scooting along here, just sliding across. If you have a flat line like this, my pretend friend Steve is walking along, this slope would be called 0. Because again, there's no up or down, it's literally just a flat line that he's dealing with. Then we have the most scary slope or ski slope that he would ever try to do. My pretend friend Steve tries to walk to the right here, he falls off a cliff. And unfortunately, then he is undefined. So the slope of a vertical line, undefined. Horizontal line, 0. As we go this way, negative. As we go this way, positive. But always reading these slopes from left to right to decide positive, negative, 0, or undefined. This is lesson 3.6b. In this lesson, we're going to be talking about slope-intercept form, which we've seen before in previous lessons. So slope-intercept form is that form that we've written out before. Y equals mx plus b, where m is our slope and b is the y-intercept. Just abbreviate INT for intercept. And remember that sometimes it doesn't always take the form of plus b, it could be minus b as well, and we'll see how that will impact our equations and our graphs as we're moving forward. So if we're looking at equation A, it says find the slope and the y-intercept of the graph of each linear equation. Okay, so if I'm looking at letter A, I have y equals mx plus b format, so my slope is 3, and my y-intercept is negative 4. That sign in front of it tells me if it's positive or negative. For question B, in example 1, our equation looks kind of similar to our slope-intercept format. However, we don't see the slope times x in there. And the reason for that, as we've touched on in the past, is because in this instance, in order for x to completely disappear, the only thing we can do is multiply by 0. So another way to write this equation is y equals 0x plus 6.5. So if we write it that way, then we discover that the slope is 0 and our y-intercept is 6.5. So anytime you see an equation, y equals a number, then I know the slope is 0, and I know that the y-intercept is whatever that number is, because I could rewrite it as y equals 0x plus that number. Now for part C, it's a little bit tricky to be able to figure out exactly what the slope and the y-intercept are based on what we have here. We have a couple of options. The first thing is we could, because it is in standard form, we could treat it the way we've treated x and y intercepts in the past. But the easiest method that we can do for this one is to rearrange our equation so that it matches our slope-intercept format. So we've got negative 5x minus y equals negative 2. So remember, in order to be slope-intercept format, we have to get y all by itself. So what we can do, for starters, to get y by itself, is we can move this negative 5x over here to the same side that negative 2 is on. So in order to do that, we would add 5x to both sides. Notice I'm not stacking them because they're not like terms. Bring down this minus y. Remember, the sign in front has to stick with that variable. And then I'm going to write this so that the 5x comes first and the minus 2 comes afterwards. Either way would be fine, but because we're trying to go with y equals mx plus b format, I opted to put the x in front. But 5x was positive, 2 was negative, so make sure you keep the signs with those. Then, because this says minus y, remember that that's the same thing as minus 1y. So in order to get y by itself, we're going to divide everything on both sides by negative 1. As a result, we're going to get y equals negative 5x plus negative 2 divided by negative 1 is positive 2. So if I have y equals negative 5x plus 2, and we're looking to figure out what's the slope, what's the y-intercept, our slope, remember it's always attached to x, so slope is negative 5, and our y-intercept is always that number that's added or subtracted to the end of our equation, so our y-intercept in this case is positive 2. For example 2, we have to graph 2x plus y equals 4, and we have to determine the x-intercept. So if I want to graph it, based on the information that I know how to use, one option that I can do is to, and this one won't take too many steps because notice the y is just y. So to get y by itself, we're going to subtract 2x. And that gives us y equals negative 2x, and that 4 has nothing in front of it, so plus 4. So what we're noticing is our y-intercept is positive 4. So put it out up here at positive 4. Make it green because that tells me where to go first. And my slope is negative 2. And remember when we talked about slope originally, I said if you have a whole number for your slope, that I would suggest making it look like a fraction. So for example, this would be like negative 2 over 1. The reason for that, remember the top is the rise and the bottom is the run. So from this first point that we plotted, we're going to go down 2, 1, 2, and right 1 space. Down 2 and right 1 space. Down 2 and right 1 space. So we're plotting all these additional dots. If I connect them using my ruler here, we notice that our graph touches the y-axis at 0, 2, right there. Or the x-axis, I'm sorry. The x-axis. So our x-intercept is the point 2, 0. And if you wanted to use your standard form equation to double check to make sure that you have the right x-intercept, perfectly fine. But that's a method that we can use to graph from slope-intercept form as well as use that graph to find our x-intercept.